Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1, Higher Tier, Paper 2, Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1 requires us to know the formula for density. Now, we should all know that density is equal to mass divided by volume. So, which one is mass divided by volume? It's that one. Question 2 is about fraction and decimal equivalence. Now, if you can't just look through this list and spot the one that is equal to 2.375, you can just type the number into your calculator and press equals. Most modern calculators these days will then convert that into a fraction in any case. So 2.375 equals 19/8. That one. Question 3 asks which of these is the equation of the x-axis. Now, if you consider points along the x-axis and what their coordinates are, this would be the coordinate 1, 0. This one is 2, 0, 3, 0, 4, 0, etc. So what do they all have in common? They all have in common that the y coordinate is 0, which is why the equation of the x-axis is y is equal to 0. The angles of a quadrilateral are 140, 80, 60 and 80, and we're asked what type of quadrilateral could this be. Okay, now what do these quadrilaterals look like? Okay, looks like that. This is my roughly drawn parallelogram, rather poorly drawn rhombus, and there's my trapezium. Now I can see from these that parallelograms have opposite angles that are equal, and so do rhombus. So it can't be that one and that one because these two go together, look, but these two are not matching, so it can't be those. So it's either a kite or a trapezium. Now a trapezium has a pair of parallel sides, which means two adjacent angles must add up to 180 degrees, and that isn't the case here either. So the only option it can be is the kite, and that does seem to fit because I've got two equal angles, which are going to be those two, and then I've got two other angles that are different in a kite. In question 5, we're told that a solid cuboid is made of centimetre cubes, and I'm given the plan, the front and the side elevation. Now, in order to get a better understanding of this, I'm just going to quickly sketch a cuboid. You can see my Drawing skills haven't improved. So the front elevation is what you can see from the front, and you can see that this is 3 units by 4 units. So this front face here is 3 units by 4 units. Now the side elevation is what I can see from this side here, and that is 3 units by 1, 2, 3, 4, 5, 6 units that way. So we've already got the 3 there, matches with the other 3. And that depth then is 6, and then I can just use the plan view, which is the view from above, which would be that face. Let's just change pen. This is going to be my plan view from the top, and I can see my plan is 4 by 6, and again that matches. There's my 4 and there's my 6, so it all ties in. Okay, so how many centimeter cubes were there to use to make this cuboid? I can just use that by using the volume formula. Volume equals length times width times height. So I'm just going to multiply those 3 things together. 3 times 4 times 6. 3 4s are 12, and 6 12s are 72. So I'm going to be using 72 little cubes. Question 6 has the times that 80 customers waited at a supermarket checkout, and that information has been put into a grouped frequency table. Now question 6a asks, in which class interval is the median? Now the easiest way to work out a median is using cumulative frequency. So I'm going to add an extra column to my table, which I'm going to put CF at the top for cumulative frequency. Now you get cumulative frequency by adding the new frequency to the existing frequency up to that point. So the first value is going to be 32, and then the next value is going to be 32 plus 19, which gives you 42, 51. The next one is going to be 51 plus 20, which is 71, and then 77 and 78, and then 80. Now whenever you're doing cumulative frequency, it's a good idea just to double check your answer here is the same as the one they give you in a question, just as a little check on your own adding up. Mine does, mine works. Now to work out where the median is the person in the middle. So if you've got 80 people, then you can find where the middle person is by adding 1 and divided by 2. So the middle person is the 40.5th person. Now where do they lie in the data? Well, we can just use our cumulative frequency to work that out. We can see that the 32 people were in the first category, and then person 33 to 51 are going to be in the next category up, and that's going to include our 40 and 41st person. So this group here then is going to be the solution. So let's ring that. Okay, so part B asks, the manager of a supermarket says 90% of our customers wait less than 6 minutes. Does the data support this statement? Okay, so going back to the data, how many people did wait less than 6 minutes? Well, the people who waited less than 6 minutes are going to be all the people in the 0 to 2, 2 to 4, and 4 to 6 category. Now we've already added that up. Cumulative frequency says there are 71 people who are in those first 3 groups. So we just need to now work out whether or not 71 is 90% of 80. So what is 71 out of 80 as a percentage? Okay, typing that into the calculator. 71 divided by 80 equals, now you see it gives you as a fraction, but if you press the symbolic to decimal button, that converts it to 0.8875 for us. 0.8875, which is 88.75%. Now the question didn't actually ask us to work out the percentage. although we do need to show our method, it asked, does the data support the statement? So having looked at our result, can we say that the manager was correct in his statement? Now actually the mark scheme, it gives you credit if you say yes or no here, depending on what you say. So you could say yes, 88.75 rounds to 90, so it was reasonable for the manager to say that. Or you could say no, 88.75% is below 90%. Personally, I think the manager's stretching it a little bit here by saying 90%, so I'm going to go with no. I'm going to say no, 88.75% is below 90%. In question 7, we are told that 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 36 people did pass. Of these 36 people, 3 times as many predicted pass as predicted fail. Complete the frequency table. Okay, so we've got quite a lot of information here that we need to fit into this graph below. Let's just take it a line at a time and see what we can see from each statement. Okay, so let's go with the first statement. 30 people predicted they would pass. Okay, so I can see we've got 50 people altogether, and of those 30 people predicted they would pass, so I'm going to write 30 in that box there. So if there were 50 people altogether and 30 people predicted they would pass, that means 20 people must have predicted that they failed. Okay, so we've used that first piece of information and it told us this number here. Now the second piece of information, 36 people did pass. Now that information needs to go in here and in here, so not really sure how we can put those 36 people in just yet, so let's just hold fire on that for a second. The last piece of information says, of the 36 people, 3 times as many predicted pass as predicted fail. So out of those 36 people, 3 times as many predicted pass as predicted fail. So that's a ratio of 3 to 1. So that's given a ratio of 3 to 1. So if I want to divide 36 people into the ratio of 3 to 1, I need to first add those two numbers together. 3 plus 1 equals 4. And then I divide that into 36. So 36 divided by 4 is 9. And then I use 9 to kind of scale up my ratio of 3 to 1. Multiplying 3 by 9 gives me 27. And multiplying 1 by 9 gives me 9. Just double check. 27 plus 9 is 36. So that's all good. So that means that 27 people predicted that they would pass and then passed. So I'm going to write 27 in that box. And 9 people predicted that they would fail and then they passed. So I'm going to write that in that box there. Now we could just finish this off by looking at what is above each of these. So if 30 people predicted pass and then of those 27 passed, it means 3 of them failed. And if 20 people predicted fail and of which 9 of those passed, that means 11 of them failed. Question 8 tells us that Thomas ran a lucky dip stall. So he's got a lucky dip and he's selling tickets at 50p each. So I suppose he's got a bunch of tickets in the bag. People come along, give him 50p and pull a ticket out of the bag. Now if the ticket ends in 00, they win £12. If the ticket ends in a 5, they win £1.50. And there's some more information underneath. It says there are 750 tickets altogether, numbered 1 to 750. Thomas sold all the winning tickets and some of the losing tickets. He made a profit of £163 altogether. How many losing tickets did he sell? Okay, so to work this out, we're going to have to do several things. And you can see this is a 6-mark question, so there will be at least 6 things we need to do along the way. I think what we're going to need to be able to do first is work out how much he pays out in prize money. And then if we add that to his profit, we'll know then how much money he had altogether coming in. And then we can work out how many tickets he sold. So let's work out how many winning tickets there were to start with. Tickets ending in 00, how many of those are there between 1 and 750? Well, if the number ends in 00, then the first winning ticket is going to be 100, and then the next winning ticket 200, and so on down to 700. So there are going to be 1, 2, up to 7 winning tickets ending in 00. So it's going to be 7 of those. Now what about tickets ending in 5? Well, we're going to have the number 5 itself, and then the next ticket ending in 5 will be 15, and the next one 25, and so on. So how many of those are there? So I suppose up to 95 there are going to be 10 tickets. So there are 10 tickets in 100. So in 700 there'll be 70 tickets, and then there'll be another 5 tickets between 700 and 750. So that makes 75 tickets ending in a 5. Okay, so now we know how many tickets there are altogether of each winning type. We can work out how much Thomas paid out in prize money. So let's just make a note of that underneath. So tickets ending in 00, there were 7 of those, and he paid out £12 on each of them. Now 7 times 12 is 84. Okay, now tickets ending in 5, now there are 75 of those, and every winner paid out £1.50. So 75 times £1.50 is £112.50. 112.5. So what's the total prize money? Is those two added together. So adding on the £84 is £196.50. £196.50. Okay, so that's the money he paid out. Now after he paid out that money, he still had a profit of £163. So his total income then, how much he got altogether, is going to be his prize money paid out plus the money he's got left over. So his total income for playing the game is going to be his £163 profit plus his £196.50 prize fund, which adds up to £359.50. Okay, so he was selling the tickets at 50p each. So then tickets sold is going to be his total income, £359.50, divided by the cost of one ticket, which was 50p. So he must have sold 719 tickets. Now with these long questions, it's always a good idea just to double check that we've answered everything. And actually when I go back here, I can see that how many losing tickets did he sell? So I almost missed that. How many losing tickets did he sell? Well, if he sold 719 tickets, and there were 7 winning tickets with 00 and 7 winning tickets, 75 winning tickets ending in 5. The losing tickets is going to be equals 719 subtract the ones ending in 0, 0, of which there were 7, and subtract the numbers ending in 5, of which there were 75. So minus 7 minus 75 is 637. So he sold 637 losing tickets. Now just note how I've set this out. It's not terribly tidy, but every calculation along the way I've signposted what it is I'm doing. This will make it a lot easier for the examiner to see what it is in these longer questions and follow your chain of thought. And actually it's going to be easier for you to, after you've done the question, to go back and check your working and things like that. Your own answer will make more sense to you, so you'll be able to check it more carefully when you come through and do your checking at the end. So just a top tip, just to make sure that you signpost each step of these longer calculations, so it's clear what you're doing. Question 9 wants us to write 280 as a product of its prime factors. Now there are different methods for doing this. I quite like the factor tree method, where you start with 280 in a circle at the top, and then you think of two numbers that multiply together to give you 280. So I'm going to pick, well, let's go with 2, and 2 times what? 140 is equal to 180. Now, if your number is prime, like 2 is, that's a stop. If it is non-prime, if it's a composite number, then there will be two other numbers that you can multiply together to give you 140. So how about 10 and 14? Okay, now 10 is not prime, so it splits up as well. So 10 is 2 times 5, and 14 is 2 times 7. Now 2 is prime, 5 is prime, 7 is prime. So all of my branches are now ended. Once you've completed all of them like that, then you can say that 280 is equal to a product of all those prime factors multiplied together. So I've got 1, 2, 3 2's. So 2 times 2 times 2. I've got a 5 times 5, and I've got a 7 times 7. Sometimes it asks you to write it as a product for prime factors in an index form, in which case you'd have to go one step more and write that as 2 cubed times 5 times 7. Here it doesn't ask that, so either answer would be acceptable. Question 10 has us doing a little bit of algebra. I've got a pair of brackets to remove. So I don't know how you remember this. It might be first, outside, inside, last. Might be something like that. Or you might have a smiley face, whatever way. You can work out that you have to multiply everything in the first bracket with everything in the second bracket. Y times y is y squared. Y times negative 4 is minus 4y. 5 times y is plus 5y. And 5 times minus 4 is minus 20. At this stage here, just look in the middle for your two like terms and add them up. So I've got y squared minus 4 and plus 5 make y. So my final answer is y squared plus y minus 20. Question 11 asks us to work out the size of angle x. And I've been given two sides of a right angle triangle, 11 and 8. So when you've got sides and angles together and a right angle triangle, it's going to be trigonometry. Let's start off by labeling the sides relative to x. So this A is the adjacent, this one is the opposite, this one is the hypotenuse. So we've been given the hypotenuse and the adjacent, and we're wanting to find the angle, so we're going to be using cosine. I don't know how you remember which one it is. I use SOHCAHTOA. Whichever way you remember, the adjacent and the hypotenuse is about the cosine. cos of an angle is equal to adjacent over hypotenuse. In this case, cos x equals adjacent 8 divided by hypotenuse 11. So we want to find x now, so we're going to type this into the calculator. I'm going to do the inverse cosine of 8/11. So I'm going to type that into the calculator. Inverse cosine of 8 divided by 11, close bracket, equals, I'm getting 43.3 degrees. Incidentally, I am using an emulated version of the Casio ClassWiz in this video. The ClassWiz is a very nice calculator. I've got some videos on using it. I'll put one up in the cards now, and there's more details below. If you're carrying on with A-level maths next year, you might want to consider upgrading your scientific calculator to one of these. It is allowed in your GCSE exams. It might give you a bit of an edge. Next, I need to find length y down here. Now again, I've been given another side and an angle. So again, it's a trigonometry question. So I'm going to label up the sides like before. So this is my given angle. So this one is the adjacent and this one is the opposite. This is the hypotenuse over here. I'm not going to use either of those today. So again, which one is it? Well, I want the opposite. I've been given the adjacent, so it is tan. So tan theta is equal to opposite over adjacent. So subbing in from our diagram, tan 40 equals the opposite y divided by the adjacent 37. Okay, rearranging for y equals 37 tan 40. Look, I can just take that 37 there and move it up there. That's what I'm doing. And I can type then 37 tan 40 into the calculator, which gives me 31.04 in a bit. I'm going to round that off to 3 significant figures. So I'm going to round that down to 31.0. So my answer is 31.0 centimeters. Okay, now with all these sorts of questions, it's always good just to have a quick glance back at the diagram. Does 31 centimeters look sensible in that diagram? So if that one was 31, look, this one's 37, it kind of makes sense, doesn't it? It sits all right in that diagram. It's just a visual check, another way of just checking your work as you're going through. Question 12 has a water tank, which is a cylinder with radius 40 centimeters and depth 150 centimeters. We're told that it's filling at a rate of 0.2 liters per second, and we're being asked, does it take longer than an hour to fill the tank? Well, in order to answer that question, we need to know what the capacity of the cylinder is to start with. So let's do that first. What's the volume of this cylinder? Well, a cylinder is a prism, and the area of a prism is equal to its cross-sectional area times its length or its height. So we need to work out what this bit is here. Okay, now that area is a circle. It's pi r squared times the height. So the volume of this is going to be, well, that's pi r squared, isn't it? So the volume of this cylinder is going to be pi r squared h. I'll leave the pi in for now. Do I want to leave the pi in? No, let's put it in. 3.14 times 40 squared times 150. So what's that? .14 times 40 times 40 times 150. So that's 753,600. Now that's in cubic centimeters. Now, we're told, we should really know this, but 1 litre is 1,000 cubic centimetres. So if it's got a volume of that, then it can hold, let's divide that by 1,000 and find how many litres it can hold. So that's 753.6 litres. Okay, so if it's filled at a rate of 0.2 litres per second, how many seconds does it take to fill up? So time taken to fill up is going to be the volume divided by that flow rate then, isn't it? So taking time is equal to 753.6 divided by 0.2. And that equals 3,768 seconds. 3,768 seconds. Now, this question is asking about time in hours. So we need to convert that to hours. So time in hours is going to be the seconds divided by 60 to get minutes, and then another 60 to get hours. So 3,768 divided by 60 divided by 60 is 1.046 reoccurring, which I'm going to round off to 1.05. So that's 1.05 hours. Okay. So, does it take longer than 1 hour to fill the tank? Well, yes it does, because it takes 1 hour and 5, 1 hour at 0.05. So the answer is yes. It takes longer than 1 hour. Question 13 has an identity, and it's asking how many values of x is x multiplied by x plus 4 equal to x squared plus 4x. Well, the very fact that this is an identity, it's got 3 lines there, not 2, which makes it an identity. That means it's true for all values of x. That's what an identity means. So that's done. Sophie sells birthday cards. She adds 30% profit to the cost price. She sells the cards for £2.34 each. She wants to increase her profit to 40% of the cost price. How much should she sell each card for? Right, so with these questions, often you've got lots of different bits of information here, and it's kind of working together a strategy to get from question all the way through to answer. I think it's sensible to start with the price that she's selling cards for, which is £2.34 each. Now this is the cost she sells the cards for, so it must already include her profit margin of 30%. So if we want to work out the cost price of the card, we'll need to deduct that profit off the card again to find out how much she actually how much the cards are actually costing her. So this part here is a reverse percentage question. So this bit here we're doing first. So I'm going to take the sell cost £2.34 and then do a reverse percentage to work out how much it's actually costing her to make it. So if she's added 30% to her original cost of 100%, that's 130%. Okay, which is a 1.3 multiplier. Now I tend to use a little triangle like this to work out percentages. And alright, final, original, and multiplier in here. So I know the multiplier, I know the final, I want the original. So the original is equal to the final divided by the multiplier. So the original cost of the card is equal to the final cost of the card divided by the multiplier. So £2.34 divided by 1.3 is 2.34 divided by 1.3. I make that £1.80. That means that the cards cost her £1.80 to make. Now, she wants to increase her profit to 40% of the cost price. So now she wants to add on 40%. So we're going to do a normal percentage here, where we want the final and we've got the original and the multiplier. So our final price is equal to our original price times our multiplier. So the original price now is £1.80, and our new multiplier is going to be 100% plus 40%, which is 140%, which is 1.4 as a multiplier. So £1.80 times 1.4 gives me £2.52. So in order to get a 40% markup, she's going to have to sell her cards for £2.52 each. Okay, we've got this rather strange calculation here, that 6 times 10 to the A plus 6 times 10 to the B plus 6 times 10 to the C gives us 6006.6. Write down a possible set of values for A, B and C. Now clearly each one of these 6's here is contributing one of the 6's in our final answer. Now actually I don't know which order it goes in, but it just says a possible set, so it doesn't matter which way round we do it. So in order for that yellow 6 times 10 to the A to give me 6,000, I'm going to need to multiply it through by 10 to the power of 3. So that one has to be a 3 to give me an answer in the 1,000 column. Now the next one along, that's just in the units. I'm just going to have to times 6 by 1, aren't I, to get a normal 6. So that's 10 to the 0. And then finally, if I want to get 0.6, I'm going to have to times it by 10 to the minus 1. 10 to the minus 1 is divide by 10, isn't it? So that can be 0.6. Okay, so that's one possible solution. And obviously, they could all go in any order, actually, because we don't know which one is delivering where, but that is a solution. It's good enough for me. Question 16 asks us to work out the equation of a line as parallel to the line y equals 5x minus 3 and passes through minus 2 minus 4. Now a quick sketch, you don't have to do this, I just like to do these sometimes. So y equals 5x minus 3, it's quite a steep line, passing through at minus 3. Now we're going to draw a line that is parallel to this, and it passes through minus 2 minus 4, so a point up here. So it has to be parallel. Okay, so these two lines look a bit wonky, but they're meant to be parallel. Right, so if two lines are parallel, it means that their gradients must be the same. So parallel, so equation of the form y equals, it's going to have to be y equals 5x plus something, because the gradient is the same. What we just need to do is to find C, the point where the line crosses the y-axis, to complete the equation. We know it passes through minus 2 minus 4, so sub in those two values in for x and y. That means that y would be minus 4. Sorry, that's my strange cuckoo clock. Minus 4, 5 equals minus 2, so x is minus 2 and then plus c. So minus 4 equals minus 10 plus c, making c equal to 10 minus 4, or 6. C is 6. So our complete equation is y equals 5x plus 6. Question 17 tells us that Joe asked 230 students how long it takes them to travel to school, and the results are shown in this grouped frequency table. This is Joe's attempt to draw a histogram to show his data. Well, Joe, I think you have not done that right, have you? What does the question ask us? It asks us to give 2 criticisms for his histogram. Well, so there's 2 very clear things wrong with this. Firstly is this bit here, the frequency. Now on a histogram, it is the area of the bar that's proportional to the frequency and not the height. So this should be frequency density, not frequency. So Joe should have worked out what all the frequency densities were and then put the bars at that height when he was drawing his histogram. The other thing that Joe's done wrong is his scale on the bottom here. So from here to here is 5 units, here from here is 5 units, but here from here is 10 units. This is 10 and this is 30. So he's using a non-uniform scale along the bottom here. So he's drawn all his bars the same width, but they represent class intervals that are very different. This has got an interval of 5, this has got an interval of 5, this has got an interval of 10, 10 and 30. So these should be the width of those bars, not just a uniform width like he's got here. So let's write that down. My 2 criticisms are Joe should have calculated frequency, density, and used this for his y-axis scale. And our second criticism is Joe has drawn all the bars with the same width and not used the class interval. Question 18 gives us a frequency table, well, a group frequency table, and we need to draw a cumulative frequency graph to go with it. Now, in order to draw a cumulative frequency graph, we're going to need cumulative frequency. They've handily left us a column on the end here to calculate it. Cumulative frequency goes in here. We already explained this earlier, but that one is going to be the same as that. The next number you get from adding the number above with the number to the left. So this one here is going to be 9, and then the next one is going to be 44, next one is going to be 74, and then 84, 92 and 100. And when you get to the end of the list, always a good idea just to check that you've got the same number as you should have. They haven't told us how many we should have here, but it's a nice round number, so I'm happy with that. Okay, so now we've got this, we're going to be plotting cumulative frequency, these values here, against upper class bound. We're going to be plotting against these numbers. Okay, so the first point I need to plot is 80 against 0. So 80 goes with 0. The next point is 9 goes with 100. So 100 goes with 9, and so on. I'm going to plot all the others. So I'll pause this, plot the others, and get back to you. Okay, having drawn plotted all my points, now I need to join them up with a nice smooth curve. It's kind of easier said than done on the computer, but I'll do my best. Try and pass through the center of each of the marks that you made. Okay, that's all right. So you tend to get this S-shaped curve with cumulative frequency. If your graph starts heading downwards again, obviously you've made a mistake. Right. Estimate the number of these films with a running time of less than 2.5 hours. So 2.5 hours is how many minutes? That's 150 minutes, isn't it? So what we need to do is read up from 150 and across. So let's get the ruler out, put it on 150. Oops. So we're going to draw up from the 150 until we hit the curve. Right, okay, so this value here is 82. So estimate the number of films that have a running time of less than 2.5 hours. It should be 82 films. Okay, question 19. W is directly proportional to y and w is inversely proportional to x squared. And part A wants us to find w when y is 9, and it gives us a pair of values for y and w that go together. Okay, let's start off with the relationship. W is proportional to y, which means w is equal to k times y. Now we're given two values that go together, so when y equals 4, w equals 14, so we can sub those in to find k. So 14 equals k lots of 4. Rearranging for k is equal to 14 over 4, which is 7 over 2. Okay, so w equals 7 over 2 lots of y. Okay, we still need to work out the value of w when y is equal to 9. So subbing that into the equation, so when y equals 9, then w is going to be 7 lots of 9 over 2. 7 nines are 63, so that's 63 over 2, which is 31.5. Part B is to do with the relationship between x and w. Now you remember that w is inversely proportional to x squared. So let's write that down first. W is inversely proportional to x squared. Okay, so we're then replacing that little proportionality symbol, making it an equation. We get w equals k over x squared. We've got a pair of values that go together which can help us find k. So using the fact that when x equals 2, w is equal to 5, we can say that 5 must be equal to k over 2 squared, which is 4. Cross multiplying that, I get k equals 5 times 4, which is 20. So our final equation is, I don't know, space on this one, is w equals 20 over x squared. Now asks us to work out the value of w when x is equal to 10. So subbing in when x equals 10, w then is going to be 20 over 10 squared. 20 over 10 squared is 100, so I'm going to get 20 over 100, which is 2 over 10, which is 1 over 5, 1/5. So the answer is w equals 1/5. Now the last part of the question asks us for the relationship between y and x and asks us to pick the graph that best describes it. Now our relationships we've been given between w and y and w and x. We were told that w was proportional to y, and we've been told that w is proportional to 1 over x squared. So by chaining these together, if w is proportional to y and w is proportional to 1 over x squared, that means that y must also be proportional to 1 over x squared. Okay, so if that's a relationship, if y is inversely proportional to the square of x, then clearly it's not this linear relationship here. This is a quadratic. This one is exponential. So I don't think it's that one either. It's got to be this one here. This is the reciprocal function, isn't it? Reciprocal curves are either one up, one down if it is a odd number power, and both up like that if it's an even number power. So it's going to be that one. Question 20 starts off by describing an iterative process to find approximate solutions to x cubed plus 5x minus 8. It's got a flow diagram that you have to go around and work it out. And the question is asking us to use the iterative process to find a solution to 4 decimal places of x cubed plus 5x minus 8 is equal to 0, starting with the value of x equals 1. Which means we need to take the value x equals 1 and feed it into this process and see what happens. So let's do that then. I'm going to start by inputting the value of 1, so x is equal to 1. Work out the value of 2x cubed plus 8 all divided by 3x squared plus 5. Now that's easy, why x is 1. X cubed, 1 cubed is 1, times 2 is 2, plus 8 is 10. So that's 10 divided by 3x squared. 1 squared is 1, times 3 is 3, plus 5 is 8. So 10 over 8, which is 5 over 4, which is 1.25. 1.25. Is your answer to 4 decimal places the same as your value for x? No, it's not. So use your answer to 4 decimal places as your next value of x and start again. Okay, so I'm going to go back up to the top and I'm going to make 1.25 my input value. Right, I'm not going to be able to do this sum in my head this time, so it's time to reach for the calculator. Now this is going to be an iterative process, so I want to be able to feed my answer back into the calculator again and again without having to retype everything. So I'm going to start off by pressing the number 1 and then equals, so that will store the number 1 as the last calculated answer. And then I'm going to type in this long expression based on that answer. So I'm going to type in open bracket 2 times answer cubed plus 8 close bracket divide by open bracket 3 times answer squared plus 5 close bracket. Oh no, pressed the wrong key. Close bracket. Now when I press equals, it will feed in the answer 1 because that was my last calculated value, and it should spit out the 1.25 that we just calculated. There it goes, 1.25 or 5 quarters. So that was the result after going around once. Now if I press equals again now, it will feed in that 5 quarters or 1.25 back into the iterative function, and it should give us the answer that we get the next time round, which is 381 over 310, which is a decimal number, is 1.25. 1.290. We need to do these to 4 decimal places, don't we? So let's start that one. Okay, so let's write this down as a table. So the first one was 1. Let's rewrite that. The first solution was 1, and then we had 1.25, and now we've got 1.2290. Okay? Right, so now we need to feed that answer back in again. I just need to press the equal sign, equal key again, and it will feed that next number back in. Now I've got 1.2289. Is my answer to 4 decimal places the same? No, it's still different, so I'm going to press equal again. And I've got 1.2289 again. So now it is the same. These two were the same on my last go. So I've kind of reached the end point. This is my approximate solution to the equation, 1.2289. So my answer is 1.2289. Okay, by substituting your answer to part A into x cubed plus 5x minus 8, comment on the accuracy of your solution. Okay, so basically we're now going to have to put this horrendous value into this equation and calculate what we've got. So if x equals 1.2289, then x cubed plus 5x minus 8 is going to be 1.2289 cubed plus 5 lots of 1.2289 minus 8. Let's type that into the calculator. 1.2289 cubed plus 5 lots of 1.2289. Okay, that comes out to be 0.0003789. Very small number. Okay, so this answer is very close to 0, which would mean that our answer is fairly accurate then, doesn't it? So close to 0, so approximation is accurate, or very accurate. Okay, so we've got a rather complicated looking diagram here. We're told that ABCD is a parallelogram, and we're told that CE equals CF, which basically means that that triangle is isosceles. And we need to show that x equals y. Okay, so we need to work out the relationship with those two given angles. Now, what we're going to have to do then is we can start with this angle down here, the 2x. Now we know that opposite angles in a parallelogram are equal, so that one's going to be 2x as well. Why did I write down y? 2x, and then we can use angles at a point being equal to 360 to find that angle inside the isosceles triangle, and then we can then work out what the tips of the isosceles triangle are. So that's my basic strategy. Okay, let's start writing that up. So now the angle with the 2x in it, which is angle BAD, is equal to the other opposite angle in the parallelogram, which is angle DCB. Just going to write opposite angles in parallelogram. And then we can say that then 2x plus 90 plus 90 plus angle ECF is equal to 360. That's from angles at a point. So that means ECF, angle ECF, is going to be 360 minus 90 minus 90, which is 180, is 180 minus 2x. Okay. Right, so now we know that ECF, which is the top of our isosceles triangle, is 180 minus 2x. We can say that angle CEF, which is the angle we were looking for, angle CEF, now that is going to be, well, 180 degrees minus the angle at the tip, minus 180 minus 2x, divide by 2, because it's an isosceles triangle. So 180 minus 180 minus 2x is 2x over 2. So CEF equals x, but we're also told that it's equal to y. So therefore x equals y. Question 22 has got a Venn diagram showing information about a coin collection. Now we're told this curly E is the universal set, and we're told there are 120 coins in the collection altogether. T is the set of coins from the 20th century, and B is the set of British coins. So obviously there's a bit of an intersect where the British coins from the 20th century are. Okay, and we're told that a coin is chosen at random. It is British. Work out the probability that it's from the 20th century. Okay, now before we do that, I think we need to evaluate all these different parts of the diagram. We know the overall number in the universal set is 120, so we can form an equation in X and solve it first in order to work out what the actual numbers are in each of the sections of the Venn diagram. So let's do that first. Okay, so all the different regions of the Venn diagram should add up to 120. So we've got the x, lots of x minus 15, plus the x minus 2, and plus the 32, which is outside both sets, and that is equal to 120. So we're going to have a quadratic in x, aren't we, here? So multiplying out those brackets, we're going to get x squared minus 15x plus x and x is 2x minus 2 plus 32. I'm going to combine that into plus 30 equals 120. So x squared minus 15x plus 2x, that's x squared minus 13x, and bringing the 120 over to this side as well. 30 minus 120 is minus 90 equals 0. So we end up with a quadratic that looks like this: x squared minus 13x minus 90 equals 0. So we've got a quadratic equation that we need to solve. Always worth trying to see if we can factorize them first, because that's a lot easier than the formula. So can we think of two numbers that multiply together to give us negative 90 and add up to negative 13? Thinking about the factor pairs of 90, 90 has factor pairs 1 and 90, It has 2 and 45. 3 goes into 90 30 times. Does 4 go into 90? Yep, it does. It goes in... No, it doesn't. 5 does though. 5 goes in 18 times. Does 6 go into 90? Yep, it goes in 15 times. 7 doesn't, 8 doesn't, 9 does, 9 and 10. And I've kind of met myself coming down the other way now. So I think they are all the factor pairs. Now, do any of these factor pairs have a difference of 2? Sorry, a difference of 13, isn't it? So a difference of 13. These do 5 and 18. So x and x, 1 plus 1 minus, because our answer is minus. And the larger one is going to be the negative one, because I get minus 13x. So the 18 goes here and the 5 goes here. Now that gives us solutions for x of x equals minus 5 and x equals 18. Now whilst those two are both mathematically correct, in the context of this problem the negative solution can't happen because I've got x coins in the middle here. I can't have minus 5 coins there. So although minus 5 is a solution to the equation, it's not a solution to the problem. X equals 18 is the solution. So now I know that x is equal to 18, I can put values for each of these regions on my diagram. So that means I've got 18 in the middle there. This one is x minus 2, so that's 16. And the other one is going to be 18 times 18 minus 15. 18 minus 15 is 3. 3 lots of 18. What's that? 54. 54 go in there. I think it's worth at this point just double checking and adding up all your regions and double checking they add up to 120. 54 plus 18 plus 16 plus 32, that adds up to 120. Okay, any little checks that you can do that for yourself along the way means that, well, you're not going to get any surprises when the marks come back from the test. Okay, but have we finished yet? A coin is chosen at random. What is the probability that it's British? Okay, so we haven't quite finished yet. We need to work out a probability. Work out the probability that it's from the 20th century. So we already know that it's British, so we know it must be inside the B circle. So it must be one of 18 plus 16 coins. There are 18 plus 16, that's 28, 30, 34 British coins. So number of British coins is 18 plus 16, which is 34, and number of British coins that are also from the 20th century is 18. Oops. So the probability that it is 20th century, given that it is British, is going to be, well, there are 18 there, aren't there, to pick from, out of a total of 34. Oops, 34. So 18 over 34. Okay, question 23 has a speed time graph for a car journey. So we've got time along the bottom and speed up the side, and we need to estimate the acceleration at 6 seconds. Now acceleration is the gradient of a speed time graph. So if we have a look at the graph at the point where t is equal to 6, so reading up from 6, we're talking about this point here on the graph. what is the gradient of the graph at that point. Now you notice it's a curved section of the graph, so it's not about taking 2 points on the line and working out the gradient. What we need to do is we need to take our ruler and draw on a tangent at that point. So we try and get the ruler to just touch the point so that the gaps between the ruler and the line either side are about the same, and then we can draw on our tangent at that point. Okay, and then we need to find the gradient of that line. Okay, so taking 2 points on this line, let's take this point here, that's the point 0, what's the scale here? Each one of those little squares is 1/5 of 2 units, isn't it? That's not very helpful. So 5 divisions between 2 units means that each division is 0.4, so I would read that one as 3.2. So this point, coordinate down here is 0, 3.2. Let's pick another one further up. Let's pick this point up here at 10. So when x is 10, or t is 10, what's that then again? It's about 3 squares up, so 10, 11.2. Okay, so then we need to work out what the change in y and the change in x are between these 2 points. So let's draw on a triangle. So how far is it in the direction of y? Well, 11.2 subtract 3.2 is 8, and in the direction of x, 10 take away 0, easy peasy, it's 10. That's a bit why I picked those points. So now I know that, I can work out the gradient of the tangent. So gradient of tangent at x equals 6. Gradient of tangent is equal to change in y, 11.2 minus 3.2 over 10 minus 0, which is 8 over 10, which is 0.8. So the acceleration then is 0.8 meters per second per second. So meters per second squared. Being very naughty here and writing over the lines. Don't do that in the exam. Part B wants us to estimate the average speed of the car for the journey. So we all know that average speed equals total distance travelled divided by time taken. Okay, so basically we need to know, we know the time taken, but the distance is what we're going to need to work out. Now you'll remember that the distance on a speed time graph is given as the area under the curve or under the graph. Okay, now this graph is made up of 3 distinct parts. I can divide it up into a triangle, a rectangle, and this rather more difficult shape here with a curved edge. This is the bit I'm going to have to estimate. I'm going to have to estimate the area of that section. Okay. Now, probably the easiest way, but most rough and ready way of estimating is saying, well, let's just assume, rather than having a curved thing like that, let's make it into a triangle and then work out those 3 areas. So working out this area, and the area of that triangle underneath there. Now obviously it's going to be a underestimation of the area because I've got that shape in the middle that I won't have calculated, but it's an estimate and I think it's going to be good enough for our purposes. So this area here is a triangle, so it's a half base height, isn't it? So that's going to be a half times 18 to 24 is 6 times a height of 12. So half 6 is 3, 3 6s are 36. This bit here is a rectangle, so just length times width. It's going to have an area of 14 to 18 is 4 times a height of 12. 4 12s are 48. And then this bit here is a triangle, so again half base times height, which is a half of 12 times 14. Half of 12 is 6. 6 14s, what's that, 84? Okay, so let's write that in our answer sheet. It's 84, 46, and what was it? 36, 48, and 84. 48, 84, and 36 over total time taken. Well, the time of the journey was 0 to 24, so it took 24 seconds over 24. So let's add that up. 84 plus 48 plus 36 is 168 divided by 24, and 168 divided by 24 is 7. So average speed is 7 meters per second. So 7. Okay, now the last part of the question says evaluate your answer to part B. Is it an underestimate, an exact value, or an overestimate? Well, as I said earlier, we have estimated this area under the curve section to be a triangle, so we've missed off this bit in here. Okay, so we have underestimated the distance that was travelled in the time taken. So if in our calculation the distance was low, then we've got a low number divided by a number, so this speed then is going to be a low. It's going to be an underestimate. So, oops, it's going to be an underestimate. We need to write a comment with that, so so what did we do? We estimated area under curved section to a triangle which was less than the area under the curve. Okay. So we get to finish off the paper with a 5-mark algebraic fractions question. What joy. Okay, so we've got a complex looking pair of fractions multiplied together, and we need to show that it simplifies to a slightly nicer looking algebraic fraction. Okay, so we know about how to combine two fractions together normally. If I have a much simpler fraction like a over b times c over d, we would just say that, wouldn't we? We would say AC is equal to BD. We'd just multiply the top with top, bottom with bottom, and then we'd see if we can cancel anything out. That's exactly what we're going to do here. We're going to put all of this over into one fraction and then see if we can cancel anything. Okay, so let's start with 2w plus 4 over w squared minus 25 times w plus 5 over w squared plus 3w plus 2, and that's going to equal to something all over 1 divisor. So 2w plus 4 times w plus 5 over w squared minus 25 times w squared plus 3w plus 2. Now, can we cancel anything here? Just having a look at what's on the bottom of this, I've got we've got two quadratics on the bottom. Now the one on the left, this one here, is actually the difference of two squares, w squared minus 25. If you remember your identities, then a plus b times a minus b is equal to a squared minus b squared, which is what we've got going on here. So that part there becomes w plus 5, w minus 5. The other side of it, this bit here, is a quadratic. Can we factorize it? So does it factorize into two brackets? Well, if it did, it'd have a w and a w there. I have two numbers that multiply together to give me 2 and add to 3. So w plus 2, w plus 1. And that is over w plus 5 that we can't do anything with, and 2w plus 4, which we can do something with. So this part here, look. So that bit was that bit there. That bit was that bit there. That bit stayed the same, and the 2w plus 4 can become, or we can factorize 2 out of that, and it becomes 2w plus 2. Okay, so that's the blue bit. So we've kind of gone through and we've done little bits to each of those expressions. So now what? Can we cancel anything top and bottom? So I've got a w plus 2 there, which I can cancel with that w plus 2. And I've got a w plus 5 there that cancels with that w plus 5. So they all disappear. So that leaves me with 2 over w minus 5 w plus 1. Okay? So what we've done so far is we've multiplied these two things together. Now we still need to multiply that expression with this other bit on the end here, that bit. So that's the bit we're going to do next. So 2 over w minus 5 w plus 1 times 3w squared minus 16w plus 5. What's that equal to then? Well, that is 2 lots of 3w squared minus 16w plus 5 all over w minus 5 w plus 1. Now, it would be very handy if that top quadratic 3w squared minus 16w plus 5 would factorize, and I can then cancel it out with another one of my factors on the bottom. So does that break up into two brackets? Well, if it does, it's going to have a 3w here and a w there, and the numbers are going to have to multiply to 5 and add to minus 16. So if we put a minus 5 in there and a minus 1 in there, then that kind of works, doesn't it? So 3w times the minus 5 would give me minus 15w, and the minus 1 times the w would give me minus w, give me minus 16w altogether. So that does work. Right, so then can we cancel anything now? Again, I've got W minus 5 there and a W minus 5 there, so they can cancel each other out. And I'm left with, what's left? We've got a 2, we've got a 3W minus 1 over W plus 1. Now, is that of the right form? Let's have a look back. Show that it simplifies to AW plus B, CW plus D. We're almost there. I think what it wants then, to make it into that form, I just need to multiply out the top part. Seems a bit counterintuitive, but let's do it. 6W minus 2 divided by W plus 1. Now that seems to be in the form required. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too, and if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.